Today's video is about the general conic form of a parabola. A parabola is a set of all points in a plane that are equidistant from a fixed line called the directrix, and a fixed point not on the line called the focus. Every conic section can be written of the form ax squared plus by squared plus cx plus dy plus e equals 0. And if your a or b equals 0, then you know you have a parabola. So if you just have one squared term in this equation, then you know you are looking at a parabola. And so as you see here on the screen, we have different types of parabolas. We could have parabolas that can open up or down, and you'll know you have that type of parabola if your x term is squared. You'll have a parabola open left and right if your y term is squared. And of course, we will look at the sign in front of the other variable to see if it's positive or negative. So if that number that we factor out, and you'll see when we do examples, is positive, then the parabola will either open up or either open to the right. If the number is negative, then the parabola will open down or to the left. And to describe a parabola, we need four things. We need the coordinates of the vertex. We need the equation for the axis of symmetry. We also need the coordinates of the focus and the equation of the directrix. So let's do some examples that will illustrate this. So what we want to do first is we want to write the equation in standard form. As you can see here, this only has an x squared term involved. So we know this is going to be a parabola for sure. So what I want to do is group my x terms together. And then what I'm going to do is I'm going to subtract the other terms to the other side. So the 8y and the 4 will go to the other side. So you get negative 8y minus 4. I'm sorry, plus 4. And now you want to get ready to complete the square. So we have x squared plus 4x plus blank equals negative 8y plus 4 plus blank. And when you complete the square, you take half of 4, which is 2, and square that result, which is 4. So whatever you put there as well. And then you get x plus 2 all squared. Take half of 4, which is 2. And then, of course, simplify the right side. You get negative 8y plus 8. And then you want to factor out the number in front of y, which here is negative 8. So you get x plus 2 all squared equals negative 8 times y minus 1. And so as you can see here, we have a parabola that opens downward because your x term is squared and the 8 is negative. So what I'm going to do is I'm going to do a rough sketch of this parabola. So I have a parabola that does this, and I have my vertex here. My focal point is here. Then I'm going to do my axis of symmetry that goes through both of those points. And then so that's my axis of symmetry labeled at A. And then I'm going to label my other line here. It's up here. And that's my directrix line. So before I describe this parabola, I need to find my p-value. So p will be negative 8 divided by 4, which is negative 2. Well, my p is negative 2. I need that value, so when I get ready to describe the parabola, I'll be able to utilize the p-value. So we have a parabola with vertex -2. Okay, it's going to be -2, 1. Okay, my axis of symmetry is x equals -2. My focus is going to be -2, 1 plus -2, which gives me the point -2, -1. And then my directrix is y equals the y coordinate, which is 1, minus -2, which gives me y equals 3. Okay. So vertex is at -2, -1, -2, +1. The axis of symmetry is x equals h, which is the x coordinate here. Your focus point is 2 units. It's going to be p units below the vertex. P units below the vertex. So you subtract 2 from. So pretty much go 2 units below here. P units below the vertex in this example, which is -1. And my directrix is a line that is p units above the axis. Okay. P units above the vertex. Here's our next example. We're going to do the same thing. So we're going to group, in this case, our y squared term is present. So we're going to group our y squared terms together. But then I'm going to add 8x to the other side and 7 to the other side because they are both negative here. And now I'm ready to complete the square. So when I complete the square here, take half of -6, which is -3, squared is 9. So if I add 9 there, I add 9 there. So now I can rewrite this as y minus 3 all squared equals 8x plus 16. Now I'm going to factor out here my 8, because that's the term in front of x. So I get 8 times x plus 2. So I'm going to go ahead and find my p. So p is 8 divided by 4, which is 2. So this is a parabola that opens to the right. So let me do a rough sketch here. So my vertex is there. My focal point is there. My axis of symmetry goes to the vertex and the focal point. And then my directrix is outside my it's outside my parabola, or to the left of this parabola. Okay, so we're ready to describe our parabola. So it's a parabola with vertex -2, +3. Okay. Axis of symmetry y equals -2. My focus is p units to the right of my vertex, so I'm going to add p to the x coordinate, so it's at 0, 3. And then my directrix is p units to the left of the vertex, so it's x equals 1. That is our parabola. Here's our next example. Again, we see the y squared term only present here, so that means we'll move the x terms to the other side. In this case, we get negative 12x plus 20. And we're going to complete the square. So this would be, take half of negative 8, which is negative 4, and then you square it, it's 16. So adding 16 over here to the left, we add 16 to the right as well. And then we're going to factor. So we get y minus 4 squared equals negative 12x plus 36. And here we're going to factor out our negative 12. So that leaves x minus 3. Okay, so we're going to compute our p. So our p is negative 12 over 4, which is negative 3. So we have a parabola that opens to the left. So let me go ahead and do my rough sketch up here. So my vertex is here, my focus is here. My axis of symmetry always goes through the focus and the vertex. And my directrix is outside the parabola. So in this case, it's going to be to the right of the parabola. We're ready to describe this parabola. So we have a parabola with vertex 3, 4. Axis of symmetry is y equals 4. Our focus is going to be at 0, 4. And our directrix is going to be at x equals 6. Okay, so remember, the focus is p units to the left. It's p units to the left of your vertex. So we have to subtract 3 from our x coordinate of the vertex, which gives us our focus 0.04. And then our directrix, okay, our directrix is going to be p units to the right of our vertex. So you add p to this and you get 6. So here's our last example. So here our x squared term is present. So we'll group our x terms together. And then we'll move our y term and constant to the other side. And then we're going to complete the square. So when we complete the square, we get 9 here. So we add 9 to the left and 9 to the right. Now we have x minus 3 squared equals 4y plus 4. And we're going to factor out the 4. And then we're going to find P. So P is going to be 1. So this is a parabola that opens upward because our x term is squared and our P is positive. So it's going to do this. So here's our vertex. Our focus is in here. Axis of symmetry, remember, always goes through the focus and the vertex. And then our directrix is on the outside of our parabola. All right, so this is a parabola with vertex 3, -1, axis of symmetry, x equals 3, focus is at 3, 0, and our directrix is y equals -2. There's our parabola there. So again, to describe a parabola, we'll need to complete the square to write it in standard form, solve for P, and then describe the parabola by finding the vertex, axis of symmetry, focus point, and your equation of the directrix. Thank you, and you have a great evening.